Now we're going to be looking at graphing rational functions. So I just want to remind you of what f of x equals 1 over x looked like. And we looked at that one on Desmos. And it was a function that had a swoop and a swoop. This one had a vertical asymptote at x equals 0. It also had a horizontal asymptote at y equals 0. Some other key features would be its domain and its range. Well, its domain are any values except for 0, so x cannot be 0. And guess what? The range is directly correlated to the horizontal asymptote, so y is not 0. Now, other key features of graphs are our x-intercepts and y-intercepts. In this particular one, it's not crossing the x-axis or the y-axis, so there's none. But just thinking about what happens, what if I took that function and did 1 over, let's say, x minus 3, and then put a plus 2 at the end? What would that do to this graph? Well, if we remember our transformations, the plus 2 at the end would move the whole graph up 2. This is going to move the whole graph right 3. So, if I go right 3 steps, that's going to move that vertical asymptote to x equals 3. 1, 2, 3. That's my vertical asymptote at x equals 3. It's going to move the whole graph up 2, so that's going to move my horizontal up 2. So the horizontal asymptote would be at y equals 2. It still has the same shape, but the horizontal and the vertical asymptotes would just shift depending on how I moved up, down, right, left, etc. Now, they get a little bit harder when it's not just transformations. So I'm going to take, this will be my first real number 1. Let's take the function 2x minus 1 over x minus 1. Okay. Let's find all the goodies. So I'm going to break it down. We're going to find our x-intercept. We're going to find our y-intercept. We're going to find our vertical asymptote. And we're going to find our horizontal asymptote. Okay. So how do we find an x-intercept of any graph on Earth? Well, x-intercepts are when y is 0. So let y equal 0. So I'm going to set this whole thing equal to 0. Now I have a fraction. Ooh, that's getting a little fuzzy. Okay. And if I make this equal another fraction, I can cross multiply. So I'll have 2x minus 1 times 1 equals x minus 1 times 0. And now I have to solve. So I'd add 1, then divide by 2. That's going to give me x equals 1/2. So my x-intercept is the point 1/2, 0. By the way, this section is really, really important. We are going to be actually using this section to do the core project for TJC. Okay. Y-intercept. So x-intercept, let y be 0. Y-intercept, let x be 0. So I'm going to call f of x y. 2 times 0 minus 1 over 0 minus 1. That's going to give me negative 1 divided by negative 1, which is just a 1. So my y-intercept is going to be 0, 1. Now, when does a vertical asymptote happen? Well, it's when the denominator equals 0. So I'm going to take that x minus 1 equals 0 and get x equals 1. Now, guess what? That also tells me my domain. X cannot be 1. Horizontal asymptote. This is where we're going to divide. So we have like degrees. So if I take that 2x divided by x, I'm going to get y equals 2. Now the beauty of a horizontal asymptote is it gives me my range. If my horizontal asymptote is at y equals 2, then my range is y cannot be 2. So let's see if we can graph that. Shoop. Shoop. 2. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. I have an x-intercept at a half. I have a y-intercept at 1. My vertical asymptote is at x equals 1. That's a vertical line right there. Horizontal asymptote was at y equals 2. And so since I know I have to go through those points, I know this graph is going to go this way. And then the other side of it is going to be kind of cat-a-corner. It's going to be going that way. Let's try another one. Two. Okay, so we're going to do all the same things. X-intercept, y-intercept, vertical asymptote, horizontal asymptote. Okay, so we're going to set y equal to 0. So 3x plus 2 over x minus 4 equals 0 over 1. Cross multiply, and I get 3x plus 2 equals 0. Then solve for x. So I'd subtract the 2, then divide by 3, and that is my x-intercept. Y-intercept. Set x equal to 0. So I end up with negative 1/2 there. Vertical asymptote is when the denominator equals 0. This means my domain is going to be x cannot be 4. Horizontal asymptote. Divide. So I'm dividing the 3x and the x. I get y equals 3. So the range is y is not 3. Okay, so I've got to make sure I go all the way to 4 and 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. 2, 3, 4. 1, 2, 3. Okay. So my vertical asymptote, actually let's start with the x-intercept, is at negative 2/3. X at negative 2/3 is right about here. The y-intercept's at negative 1/2. Vertical asymptote at 4. 1, 2, 3, 4. Horizontal asymptote goes this way. So I know I got to go through those 2 points. And the other side is going to be catty corner. Let's do a couple more. I'm going to factor. I'll do the hard part. X and X multiplies to be negative 6 and adds to be a negative 1. Nothing cancels, so there's no holes. That's helpful. Okay. X-intercept, Y-intercept, vertical asymptote, horizontal. Now, if you haven't noticed that when we do this cross-multiplying thing up here, it always ends up being that I set the numerator equal to 0. So I can kind of take a little shortcut here and just make the numerator equal 0. Because when you cross-multiply, the denominator is just going to go away anyway. Y-intercept, let x equal 0. And I'm going to use the original. Well, everything that had an x in it basically just goes away. And I'm left with 4 over negative 6, or negative 2/3. So that's the point. X is 0, y is negative 2/3. Vertical asymptote, denominator equals 0. So this time we have 2 factors. That means we have 2 vertical asymptotes. So I invite you, if you want to go put this in Desmos and see what it looks like, you can. The denominator was bigger, is bigger. It's an x squared, so x divided by x squared, it can't go into it. So that means my horizontal asymptote is y equals 0. And I'm going to put quote. Sometimes it is not a strict horizontal asymptote unless they divide evenly. If you actually look at the graph, this one actually does cross the x-axis. It crosses when y is 0 because we do have an x-intercept. So it's not a strict horizontal asymptote in this problem. Okay. So negative 4, 0. I have an x-intercept there. I have a y-intercept right here. I have a vertical asymptote at 3. And another one at negative 2. Now I've already looked at what this graph does. And it does something like this in the middle. Touches that. Then it's going to go 2 catty corners. But over here we have something weird that happens. it actually does cross that horizontal asymptote. And I can get into the more of the details on that at a later time, but right now just know that that can happen. Last example, because we have not done one that had a bigger numerator. Would be x minus 5, x plus 1 multiplies to be negative 5 and adds to be a negative 4. Nothing cancels. For the x-intercepts, we can kind of skip a step and just let the numerator equal 0. Whoops, 1. So I have 2 x-intercepts. The y-intercept happens when x is 0. So everything with an x is basically going to go away, and I'm going to be left with the negative 5 divided by negative 3, so that's 5/3. Vertical asymptote, I'm looking at the denominator, equals 0. Just a reminder, that means my domain is x is not 3. Horizontal asymptote, this was divide. But since the numerator is bigger, there is going to be no horizontal asymptote. It's actually going to be a slant. Oops. And I wish I'd brought my graphing calculator home so I could show you these. You can always do them in Desmos and kind of see what they look like. Just remember, in Desmos you want to put parentheses around everything. Alright, so 1, 2, 3, 4, 5. I've got an x-intercept here. I got another one here. 5/3. That's almost at a 2. Vertical asymptote is at 3. So it's still a strict vertical asymptote. It's not going to cross that. And what ends up happening on this one is it does something like this. And this side does something like this. There ends up being a slant asymptote. And I'll show you how you can actually find that. The problem on the homework that asks you to find a slant asymptote, that part is going to be kind of a bonus on the homework. Alright, so slant asymptote. Remember I said just divide? That's what we're going to do, is we're going to divide. So if I was dividing x squared minus 4x minus 5 divided by x minus 3. I could do it using long division or synthetic. I'm going to review long division just because I know people struggle with it. So I'm only looking at the first terms. X squared divided by x goes in x times. X times x is x squared. X times negative 3 is negative 3x. Then I'm going to subtract. Negative 4x minus a negative 3x is going to leave me with a negative 1x. Negative 1x divided by x is negative 1. negative 5 minus 3 is negative 8. But for the slant asymptote, we're going to ignore the remainder. And we are just going to leave with that. So, negative 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I get this boundary that is the line y equals x minus 1.